As you start station 3, again, you're going to have several questions to answer first, and then you can start working on the directions for initiating translation of RNA into proteins and go from there. So I'm going to assume that you have paused this and answered the questions that you need to. So we're going to the ribosome, which is made of protein and rRNA. But so here we are at the ribosome, and here comes my mRNA strand. So I just built it using the directions that they gave me. They told me which RNA bases to put in there, and so I did that, and here they are. And now this RNA molecule is going to leave the nucleus where it was built, and it's coming out to the ribosomes that are in the cytoplasm, and it works its way into the ribosome. So we start here, and if you answered your questions, remember you were looking at codons, and remember codons are a set of 3 RNA bases. So our first codon is AUG. Now when you're trying to figure out, okay, well, what amino acid does that code for? We can look at a codon chart. This one's a circular one. Sometimes they are squares. And what I do is I look at my codon. So in this case, my first codon is AUG. So I start at the center. I look for A, and then I move out to U, and then I move to G. Okay, and then what I have here is it's methionine, which happens to be the start codon. So that's what tells the ribosome, hey, start making a protein because I've got a start codon here. All right, by now you should be through number 9 and you're getting ready for number 10. So since we looked up what my start codon was, now I know which tRNA needs to come along. So here comes my matching tRNA. Now here's something that I want you to notice. So it fits perfectly onto my codon. So, and it's bringing methionine. Remember, we looked that up and said, okay, that's the start codon. Now, something that you want to see here, do you see the tRNA is complementary? It fits just right into these bases. So if this was A, for it to fit onto it, this has to be U. And since this is U, this has to be A. Since this is G, this has to be C. So since it's complementary to the codon that's here, we call this part the anticodon. Not that it's against the codon, but it's complementary to the codon. All right, and so now I'm going to start to move, and I'm going to bring my next tRNA molecule. So I need to figure out, well, what amino acid needs to come next? So GAG is my next codon, so I'm going to look at G, A, and then to G. Okay, that's glutamic acid. So the next tRNA that's going to come along is going to be carrying glutamic acid. And the way for the ribosome to check to make sure, hey, did they bring the right amino acid, is if it fits, right, if that anticodon is complementary to the codon, then we know, all right, we worked. Now, as these come in, my mRNA is going to keep moving through, and the amino acid pops off of the first tRNA, right? And now I'm starting to build a protein or a polypeptide. Okay, now here comes my next tRNA. So I looked up in the chart, and here we go. The anticodon fits perfectly with the codon of CAU. So it can keep moving through. These amino acids are keeping to build. Here's my growing polypeptide. We call them polypeptides because amino acids are held together. This bond is called a peptide bond, right, which ultimately makes a protein. Okay, here comes my next tRNA. Again, it's a perfect fit. So that amino acid's going to get hooked on. Okay, again, I have UGU. Here comes my fitting tRNA. Its amino acid can get onto my growing protein. And next. Okay, I want to take a look at our last codon here. So it's UAG. So let's look at our chart. UAG. Do you see that brings us to a stop codon? I wanted to give you one more chance to look at the protein that you made so that you can answer number 20, which asks you to write the sequence of amino acids that are in your protein. So this way you can see them and get that written down.